Hello everyone, this is a continuation of the previous video on root locus. In the previous video we had discussed step 1 and step 2. So now we will start from step 3. Step 3 is where you find angle of asymptotes. Angle of asymptotes is given as theta is equal to 2q plus 1 into 180 degree divided by p minus z. Now what is an asymptote? An asymptote is a straight line which acts as guideline for branches approaching infinity. If you recall, in step 1 we had predicted that there are 4 branches and all the 4 branches are approaching infinity. Now while approaching infinity they should be guided, right? So that guidance is given by asymptote. So asymptote are straight lines which act as guidelines for branches approaching infinity. So now here we know that there are 4 poles, so p is equal to 4, and we know that there are no zeros, so z is equal to 0. So what is q here? So q is varied as 0, 1, 2 until p minus z minus 1. So we will substitute the values of p and z. So 4 minus 0 minus 1 is 3. So we should vary q from 0 to 3, that is 0, 1, 2 and 3. So now if we substitute the value of q as 0, 1, 2, 3, we will get different values of theta, and that is calculated here. So here we will see for one value. If we substitute q is equal to 0 here, 2 into 0 is 0, 0 plus 1 is 1, 1 into 180 degrees, 180 degree, 180 degree divided by p minus z is 4 minus 0. So 180 degree divided by 4, that you will arrive at 45 degree. Similarly, you substitute q is equal to 1, 2 and 3, you will arrive at theta is equal to 135 degree, 225 degree and 315 degree. So this is how you will find angle of asymptotes. So here you can make a quick note that number of branches approaching infinity will be equal to number of asymptotes. Here there are 4 branches which are approaching infinity. So we have 4 asymptotes having angle 45 degree, 135 degree, 225 degree and 315 degree. Step 4 is finding centroid. So what is centroid? A centroid is a point on the real axis where all the asymptotes are going to meet each other. There are 4 asymptotes, right? So all those asymptotes will meet at a common point on the real axis, and that point is called as centroid. And we have the formula for centroid as centroid represented by this symbol is equal to summation of real part of poles minus summation of real part of zeros divided by p minus z. Take care that you consider only the real part of poles and real part of zeros. So now here, if you observe, there are 4 poles, and what are the real parts here? 0, minus 1, minus 2, minus 3. So you have to add all of them. So you will get 0, minus 1, minus 2, minus 3. There are no zeros here, so it will be 0. So now if you do the mathematical calculation, minus 3 minus 2 is minus 5, minus 5 minus 1 is minus 6, and minus 6 divided by 4 is minus 1.5. So we have our centroid at minus 1.5. That is, at minus 1.5, all the 4 asymptotes are going to meet each other on the real axis. Step 5 is finding breakaway points. We have already predicted that minimum there are 2 breakaway points. Now we have to find where exactly breakaway point lies and whether there are more than 2. So for that, first you have to consider the characteristic equation. We know that characteristic equation is given by 1 plus g of s into h of s is equal to 0, and g of s into h of s is the given problem statement. So you substitute that here, and after substituting, if you do the necessary calculations or necessary mathematical modifications, you will arrive at the characteristic equation s power 4 plus 6s cube plus 11s square plus 6s plus k is equal to 0. Here what we have done is we have taken this as LCM. If you take this as LCM, you will get s into s plus 1 into s plus 2 into s plus 3 plus k is equal to 0. Then you do the multiplication and add all the like terms. You will end up at the characteristic equation s power 4 plus 6s cube plus 11s square plus 6s plus k is equal to 0. Once you have your characteristic equation, rearrange the characteristic equation so that you will get a value for k. So we will get an expression for k as this. If you take the terms other than k to the other side, all the plus terms will become minus. Now you differentiate k with respect to s. You will get dk by ds. So here if you differentiate, s power 4 will become 4s cube. S cube is 3s square, so 6 into 3 is 18, 18s square. S square is 2s, so 11 into 2 is 22s. Again 6s will become 6. Once you have dk by ds, you equate dk by ds as 0. So if you equate dk by ds as 0, here we are equating dk by ds is equal to 0. So again, after rearranging, you will get like this. Now this is a equation having highest order as 3, right? So you will have 3 roots. So find those roots, and here if you find those roots are minus 2.618, minus 0.381, and minus 1.5. So the dk by ds is equal to 0 equation has 3 roots, minus 2.618, minus 0.381, and minus 1.5. Now these are the possible breakaway points. I am saying possible because these are the possible breakaway points because these are not checked for their validity. Now we have to check whether these are valid or invalid. Again, to check valid or invalid, it depends on the nature of the root. If the root is real, then we can easily tell whether it is valid or invalid. But if the roots are complex in nature, then we have to use angle condition and magnitude condition. For that, we will solve a separate problem where we will choose a problem such that we will get complex breakaway points. But here in this particular problem, we have all the roots as real. So if you have real roots, there is a very simple way to tell whether these are valid or invalid. So what you have to do is substitute the value of s, which you want to find whether it is valid or invalid, in the expression for k, and find whether k is positive or negative. If k is positive, it is a valid breakaway point. If k is negative, it is a invalid breakaway point. So now let us see. We will find whether s is equal to minus 2.618 is a valid breakaway point or not. So you have an expression for k, right? That expression for k is in terms of s. So you substitute s is equal to minus 2.618 here, and you do the necessary calculation. You will get a value for k, right? So you will get value of k as 1. Now 1 is a positive value, right? Since k is a positive value, s is equal to minus 2.618 is a valid breakaway point. Similarly, you substitute s is equal to minus 0.381 in the expression for k, you will get k is equal to again 1, which is also a positive value. So s is equal to minus 0.381 is also a valid breakaway point. Next, you substitute s is equal to minus 1.5 in the expression for k, you will get k as minus 0.5625, which is a negative value. So we can conclude that s is equal to minus 1.5 is not a valid breakaway point. So out of 3 possible breakaway points, the first 2 breakaway points are valid and the s is equal to minus 1.5 breakaway point is invalid. So this is step 5. Again, regarding step 6 and step 7, we will discuss in the next video.